Okay, so in this video, we're going to talk about how the halogens fit into the activity series. So if we think about the halogens, you should associate them as being nonmetals and also as elements that have very strong attraction for electrons, specifically fluorine, but all the halogens in general have a pretty high electronegativity. So if we think about what types of agents they will act as, you should consider the fact that if they have a high attraction for electrons, they're likely to steal electrons. So what types of agents will they be acting as if they are likely to steal electrons? They're likely to act as oxidizing agents, species that cause the loss of electrons in other reactants. Now, if we compare that to how the metals behave, the metals reacted as reducing agents, and the more reactive a metal was, the more likely it was to give away its electrons and reduce something else. So the halogens will fit into our activity series, but they'll actually be in the opposite column from the metals because they are the opposite type of element and they'll have the opposite type of reactivity. So it's easiest to cover this topic if you actually just look at table 24 of the data booklet. If you look at the metals get listed on the right-hand side, and we already discussed how the higher up in the series we go, that means the stronger we are as a reducing agent. So in this activity series, table 24, lithium would be the strongest reducing agent. Okay. So the higher up we are, the stronger reducing agents are, and the more likely they are to give electrons to things lower down in the series. So lithium, if you react it with any of these species on the left that are below it, it can give electrons to any species below it on the left. So that's what we've covered thus far. If you scroll all the way down, though, you can actually see that the halogens are in this series. I can circle them here. So here's fluorine, here's chlorine, here's bromine, and here's iodine. Okay? So they actually are in the same exact series. They're just on the opposite side of the series because they are the opposite kind of element. And so in terms of redox behavior, they're going to behave in the exact opposite way. So we had talked about this before. As we go down, we're getting stronger oxidizing agents. So fluorine, the most electronegative element, is the most powerful oxidizing agent possible. Okay, chlorine of the halogens is second, bromine and iodine. So as their electronegativity increases, they become more powerful oxidizing agents. They are better at removing electrons from other things. And if we think about what reactions are actually going to take place, let's do that in a different color. We'll do that in green. Remember that electrons are given down the series. So anything from up here on the right will give electrons to things down here on the left. So a very common question, could be paper 1 or could be paper 2, is to ask you about which halogens will react with which other halogen ions. Very similar to the metal questions that we've seen, something like this, metal with which metal ion, except that with the halogens, you're expected to be able to predict the trend yourself. So if you're trying to predict which halogens will react with which ions, it's really helpful to be able to create a series like this very quickly, or if it's paper 2, to use the series. So I'm going to identify the halogen ions on the right. So what we're trying to figure out is which combinations will actually lead to spontaneous reactions. Okay, and the ones that will are any that give electrons down the series. So the iodine ions should be able to react with bromine, chlorine, and fluorine, the elements. Those should all be spontaneous reactions because the electrons are given from the ion down the series to the element. The bromine ions, the bromide ions, should be able to react with chlorine or fluorine, and the chloride ions should only be able to react with fluorine below it. And so any of the other combinations going up the series should not take place. So if we go back to this one and we think about our reactivity series, the I- should react with both of these things, and the Br- should only react with chlorine below it and not the iodine that is above it. And the chloride ions should not be able to react with either of these two elements. Okay, so if you were trying to answer this on your own on paper 1, it would probably be helpful to create a little series. where you rank F2 at the bottom, and then Cl2 here, and then Br2 here, and then I2 here. Across from them, you put their ions. So it's a little bit flipped from the metals, where we put the metals on the right and the metal ions on the left. That's because we have the opposite kind of element. So we have non-metal elements here, so we flipped how we're arranging them in our series. So I could create this series quite fast. I don't think it's too much to ask to remember that fluorine is the most electronegative and therefore the strongest oxidizing agent. And so from here, I would be able to predict which reactions should take place. So if I was given this question here, will this combination of reactants react? I would find here's Br2, here is Cl-. My answer would be no, because Cl- is below Br in the table, so that will not happen. Electrons are only given down the table from these things on the right to these things on the left. Cl- and I2 is another no. Br- and Cl2 is a yes. Br- and I2 is a no. And I- should be able to react with any of the halogens because they are below it in the table. And so these, I have 3 reactions that have taken place. If I want to write out what the products should be, it's going to look a lot like our metal single replacement reactions. I'm going to end up with 2 Cl- ions and Br2. So what was ion has now become element, and what was element has now become ion. So it works the same way for all of them. Down here, I would make Cl- and I2, and down here, I would make Br- and I2. Okay, and that's really all there is to it. It's probably 1 to 2 marks per exam, if that. So it's a kind of a small topic. It's listed in part of the periodicity option, or topic 3, having to do with the periodic table. So it just has to do with the reactivity of the halogens. Because they are opposite types of elements to metals, they show up in the oxidizing agent half of the activity series, not the reducing agent half. Fluorine, being the most electronegative element, is the strongest oxidizing agent, and you should be able to come up with the ranking of these 4 halogens on your own, like I did down here, and use that to be able to predict any of the combinations, which of them will actually lead to a spontaneous reaction.